Hello, hello. Are you live? I believe if we have time. Let's check it out. Um, yep, we are live and it's looking good so far. Shh, shh. Hello, hello. Shh. Okay, so this seems good. And alright, so guys, आज हम बनाने वाले हैं एक project. Now, even I don't know much about that. I have some, you know, idea of what I want to make, but I don't know how I'm going to make that. Flashbang warning. That was late. Okay. So there is this thing called uptime checker. This is basically, if you have a site and you have to check its uptime. For example, I have rexo.dev under my name, and if I want to check is this active or not, what I can do is I can just you know get a server, uh, then let's denote server as this, and I can just try to constantly ping this you know domain, um, let's say at an interval of um, basically, this interval depends upon, how critical your system or your website is. For example, if it's a landing page, this interval can be around 2 minutes. If it's a critical dashboard that that is being accessed all the time, it's going to be 30 seconds. So, this means that server will ping this domain after this interval. So this is basically what I want to make. I want to make an orchestration system. So we will have three servers. These servers. These servers will be in three particular regions. One region will cover Asia, another will cover Europe, and another will cover uh, America, and I think we need one more for Russia and uh, I guess China can be covered in Asia server. So I can just get the server in, you know, uh, like either I can get this server, Asian server in Mumbai, like because I'm in India. So either this can be in Mumbai or this can also be in Beijing or Singapore, depending upon how the traffic goes and comes. And this can be discussed later in the project, depending upon whether I complete it or not. Europe will cover uh, the whole Europe. Uh, I think I'll get the Frankfurt region in this. Europe. Yep, Frankfurt is in Europe. So Germany, Frankfurt, that is that region. I guess we can get this server from Hetzner. Um, America, We will have US East, and it will cover that whole part. Russia, I have no idea where should I get this server. So we will leave Russia for now. And when I go to some, website or hosting provider, I'll check it out and how it goes and all that. Okay, so what are the specifications of these servers? Each of these servers will be really tiny, 500 MB RAM, maybe one vCPU, and all. Even one vCPU is too much, probably. But yeah, so what is the idea behind this? Idea is to keep checking whether my website is active in all these regions or not. For now, there will be only these three regions. We can scale up and scale down depending upon the cost, maintenance cost, and all that. Mm, okay, so let's try to make an architecture of some sort. How I'm going to solve this problem. So, in order to solve this, we have um, our main server. This will be the wait. I don't know how to make architecture diagram. We will start with some front-end designs, some, what are they called? I guess, um, what was a skeleton diagram, I guess? That's what they call. I don't know. Anyway, so we will ask a user for domain, their domain. They will put their domain here, HTTPS, colon, rexo dot something like this. Actually, let's just put this in. Let's say we are pinging Excalibur. All right, and for the first time, there can be like uh, a go button here, and that go button will list all the different uptimes, uptime, and we can also list something like we can also list. Uh, Wait, I should probably get uh, live chat here. No? Not like anyone watches my streams here. I should probably get this live chat. YouTube. Open and all right, contact. Okay, okay. This is our panel. Yeah, this should do for now. Okay, so if you get some live chat here, I can just reply to them. Huh. Anyways, so uh, we have a domain which we will ping, and this go button will ping the domain. and it will list uh, the time to get back to it, something like that, response time. Hmm. I guess if it is working, so it can be green, and if it is not working, so we can just return an error code. Uh, Yeah, something like this for a particular region. Uh, so it's, let's say, well, let's say we can write here Frankfurt. Frankfurt gave us this response time. So what this actually tells us is that your website, your website is taking some amount of time to serve an HTTP response to this particular server, right? So this response time will represent the amount of time your website is taking to reach our servers, give our servers an 200 or 201, depending upon your, you know, code, the response code you should use in your website. Other than that, we can also have a few things. For example, we can also save data. Uh, like if we are going to uh, let people authenticate, so it will be something like what the hell? Okay. Hmm. So this can be our auth screen. For now, this will be a basic auth. It will have uh, Google Auth and GitHub maybe, and basic email and password. After this ID is created, what I can do is we can just make ourselves a DB. Now, the DB will store a few values. Uh, uh, some values I can, on the top of my head, there is ID, name, mm, the email. Although I am thinking of using clerk for auth scheme, so I don't think we need this in the DB. So we can replace ID with user ID that clerk gives us. We can also save our project ID maybe. If we allow users to make multiple projects, we can even allow them to add project IDs to the database. And for that particular project ID, we can store the logs So we will have our logs table here. Uh, what these logs will do is simple. Basically, we are, you know, pinging the domain from our server after a particular interval of, let's say, 2 minutes, 120 seconds is it? So after we ping the hmm, after we ping the domain from our servers after 120 seconds, what we are going to do is you know we are going to, I guess, get some type of response, be it error or be it, you know 200 or be it anything. We will just take that response and log it. Um, we can give it a particular ID for each log, and we can do something like code, or maybe response code is much better. And we will have a response, maybe you can store the response. It's a string, basically it's something not that big of a deal, probably, until unless they, are like the response that we are receiving, until unless it's a very large response, a very huge response that can be stored in a Postgres database, we would have to sanitize it. So we can add sanitized here. So that we can remember it. Sanitized. The spellings can be wrong. Please don't judge me on that. Other than that, there are a few things that I think should be present. Uh, they are good to have some information on. Oh, first of all, for each project, we will have a domain. Um, so for domain, instead of storing it here, I think we are going to create a project. Um, it will have a project ID and a domain associated to it. Um, it will also have something like time, ping time. I guess this will be in ms or seconds. It it totally depends upon. Yes, we are going to implement year-based planning on this. So like free for uh maybe 5 minute ping time and like $10, $20 for 30 seconds ping time. Yeah, we can do that. Yeah. In which case we can make the project itself um you know a tiered table. So we can store the tier in project itself, and we can more or less judge it's whether it is whether it requires a ping time of 5 minutes or whether it requires a ping time of 30 seconds, something like that. Uh, Mostly this should be it, and I don't think there is some problem with this. Maybe there is, but oh well, anything can happen. Hello, 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 hello. Okay, so I was hearing a echo, and we have a solution for it now. All right. So where were we? Yeah, we need to make these tables. We also need to make probably more than this, but it's like a good starting point, I think. When we start making this, we will understand what are the things we need. I just jumped quite right into it before thinking this through. So that's basically how I start each of my projects. Uh, we can also take, recommendations from Gemini or something, some other AI. Let's try it such that we can, you know, what can it do actually? It can ping different domains by different users. Uh, so at given time intervals based on the project tier, something like that. And well, here's the thing. Okay, so we have this. What we actually also need is um, we also need to store logs. I guess. User data is stored on clerk. So how should I design my DB? I'll think about it based on the data we need. We can ask it to a schema, code, and anything. Um, ba- Basically, I don't wanna, go through a lot of hassle. Yeah, last checked should be there. In the logs, timestamp for each log. Um, in the project itself, we can store a last checked. Hmm. For is up, I think we can determine that by response code. So it can be a good thing, depending upon how many is up and is down. We have to show if we have to like show around hundreds of tables, hundred of rows, and each of those rows only give me response code. I can just you know parse that response code in the front end itself and just give a response whether it is up or not for that particular time. We can also do something like um, a graph, basically that shows whether it is matlab, by that I mean uptime checker does what it does best. For example, GitHub has been up. GitHub's uptime has been going for about 59.99. Um, we can calculate this uptime based on how much it is down and for whether it is down globally or whether it is down, you know, for a particular region. We can decide based on our server responses. There is that. So I think is up. We should probably store is up because it's a boolean. It's not that big of a deal. Data retention policy. So there are a few ways in which these particular servers can be configured. The servers that are going to, you know, request things, request status codes from our domain, and we can do that by uh, we can do that with I forgot what I was going to say. Man, what the fuck? Anyways, we can either hard code this, hard code each server and use, Kafka or BullMQ as Gemini suggested, or maybe another queuing system or queuing system, and we can use that to, you know, get the status code from domain. But that is probably the worst choice we can make from this. So what we are actually going to do is we are going to pull data from like a DB. But how are we going to decide which DB is this data pulled from, or which table is this data pulled from? Hmm. Well, a project table holds URL and ID and all that stuff. And since we are going to make this project write heavy, oh, by the way, should the DB be read heavy or write heavy? Uh, I think this should be write heavy. No, not write heavy because we are going to introduce a layer of caching in front of the DB so that each of the pulled request from this each pulled request from this will go through uh, Redis, which will write all the operations, and then these will be flushed onto the server, and the server will send this to DB, and that's how this whole system will work. So we really don't need to make this right heavy because we can always also you can always just make a transaction based on the like what is this uh based on the logs that are coming in, but it needs to be read heavy because what I'm thinking about logs is that a log can be, you know, pro level secured. So each log can be its own ID. No, sorry. Each log can be its own entity and it will be connected to a project ID, and that project ID will help us to, get the response. So that is probably all the things you need. Now it will be indexed based on timestamp and project ID. and we will query the project ID and timestamp a lot. So first project ID will be like, you know, the first index of project ID will be used when all the data are, or all the logs are being shown on the dashboard, and then second one will be when a user filters a particular timestamp and we have to retrieve that data from the database. And that shows on the front end based on some charts or what kind and all that. So yeah, this should be the whole architecture. Is there something left here? We need to figure out how to create these servers on the go. Like as this main server is running, we need to figure out how this how these three servers will be created, because I don't want to create a new server until unless someone pays me some money. Uh, because I'm broke. I'm a broke college student. I ain't got no money, baby. I ain't got no money. But yeah, we are going to stall these servers for now, and we are not going to make them. Just this, our main server will be the one who will be pinging the domain, and after each, you know, representation, we can always just after each response code, we can store it in Redis, and then Redis will flush to the DB. Or, or maybe more accurate would be this. So you can remove this. Yeah, this is more like it. And then after I have nailed this workflow, I'm going to implement another worker that spawns up these small servers via. I also need to, you know, worry about deployment, and I'm going to use as a cloud provider. There are many. Can be DigitalOcean, it can be Hetzner, it can also be, you know, AWS, GCP. There are a lot of candidates for this. So yeah, um, as for coding, I don't know, man. I think this live stream is already good enough for now. I'm gonna end it here, and I'm gonna try to code some architecture in the back of the camera, and I'll do another live stream to justify that on the code I've written. Because I don't want my clerk or any other API keys to leak. So I probably not, you know, do it on live stream, but I'll record it, and I'll create a whole video if I am able to complete this project. That whole video will contain parts of this live stream and any other live stream I'll do for this project, plus the uh, off the camera part, behind the camera part, where I do, you know, some stuff, some coding and all that. So yeah, that's it for now. Bye bye.